Hi everyone, welcome to the playlist on BFS template. In this video, I'll solve this problem minimum height trees. So given a tree which is undirected graph where two nodes are connected by exactly one path and I need to return the node. If I use this node as a root, my overall height becomes minimum. So how do I solve it? We'll follow the BFS in layer wise fashion. So I start my BFS from the leaves. For example, these are some leaves. I'll start shrinking my tree from the leaves. Whenever there is a one or two nodes present, they can be my roots. So for example, in this case, if I start my BFS from 2, 3 and 0, right, these are my leaf nodes and eventually I will have 1. So 1 will be my root. And in this case, if these are my leaves 0, 1, 2 and 5, if I start from this, eventually I will have 3 and 4. So I'll start from the leaves and start shrinking my tree from the leaves, and whenever I have one or two nodes left, they can be my root node. So let's see how do we do it. Okay, so I say, okay, because I have this is in the pair of edges, I will try to convert it into adjacency list. So maybe this will be my adjacency list for all the nodes. Okay, for each edge in edges, graph of u dot append, I say okay, v is my edge, and graph of v dot append u is my edge. And now I will have my q, which is collections dot deg of nothing I have so far. All I do is for I in range of n, if this node has only one adjacent node, right? So if length of graph of I is 1, I append my ith node there, right? And now let's see total nodes is equals to n. So while I have my total nodes less than greater than 2, while like the remaining node, let's call it remaining nodes here. I say okay, I have some remaining nodes. While my remaining nodes are greater than 2, okay, let's count the number of nodes which are present inside my queue. I say okay, my nodes in level, which is length of queue. So for each node in nodes in level, okay, I pop my cur, I call it as a cur node, q dot pop left. So now if I have this, I'll try to remove the connection to this node from every other edge. So what I do is okay, for my I in range of n, okay, if graph at I contains this, right, if graph dot I dot contains a cur, I graph dot I dot remove cur, okay, or no, what I do is I need to traverse each of the adjacent of the cur. I say okay, for adjacent in graph at cur, okay, so this is like my node. For example, for this 2, my adjacents will be 1, right? So what I do is graph at adjacent dot remove cur. So I remove the adjacent of 1, which is 2. So I remove this, and now if it has only 1 as my adjacent, I will push it into the queue, like, which means okay, this becomes a leaf now. So this I removed the connection with this guy, and now I check okay, if length of graph of adjacent is equals to 1, I will append this into the queue. Adjacent I appended into the queue, and now I need to ignore these many nodes now, right? So my remaining nodes is reduced by nodes in the level, okay, and once this is done, I'll return my queue, because the queue contains the remaining set of elements. It will be 1 or 2. You can have less than or equals to 1, because to have some base cases where only single node is given. Let's see if it works. Okay, let's submit it. Awesome, it does. So I hope guys you understood what I was trying to say in the level wise BFS. All I'm doing is I'm starting from the leaf nodes, trying to shrink the adjacents with which these leaves are connected, and whenever somebody becomes a leaf now, because only single edge is there for that particular node, I'm pushing that into the queue. The moment queue has only two elements, sorry, the total number of remaining nodes are only less than or equals to 2, I return that queue. So if you have any question, please let me know in the comment section. See you guys in the next video.